Hey everybody. So, starting a new unit. Kind of a little out of order, as you can see on the numbers, but this is how we're going to do it. We're going to move this up a little bit earlier than really Unit 6 because it's kind of easy. You've seen some of it before, but there will be some new stuff also in here as well. So, be ready to learn something new. Alright. So this is our unit on radicals, or square roots, also known as square roots. There are not just square roots, but we can also take the cube root and the fourth root. Of course, looks like square root can be like that, or it can have the 2, but we typically don't put the 2. They mean the same thing. We can do the third root, and we can do the fourth root, okay? So what is square rooting a number? Well, let's first think of perfect squares. You've probably heard this before. So if it's perfect, that means it does not come out to be a decimal. So a perfect square would be like 4, okay? 4 is a perfect square because if I take the square root of it, I get a whole number, which is, of course, 2. So 4 is a perfect square. Let's start with 1. What's 1 squared? 1, yeah. So we can list our perfect squares by doing the opposite way. Taking the original number and squaring it. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is, I had a moment, 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100, and so those are your numbers of perfect squares, okay? Perfect cubes are the same idea. You just start off by doing 1 cubed, which is 1, 2 cubed, which is 8, 3 cubed, which is 27, 4 cubed, which is 64. Some of these I don't have memorized, so I'll just start reading them off. 125 is 5 cubed, 6 cubed is 216, 7 cubed is 343, and we could go on, but you get the idea. So I can, in other words, I can cube root all of these numbers, and they come out to be nice and easy integers, whole numbers. So, fourth root. You get the idea, 1 to the 4th power, 2 to the 4th power, and of course, when we increase the power, we're just increasing how many of each we multiply by. So, like, squares are times twice, and perfect cubes are times itself 3 times. So 1 times 1 times 1, this is 1 times 1 times 1 times 1, 4 times, 2 times 2 times 2 times 2, 4 times, so that's all we're doing. 1 to the 4th is 1, 2 to the 4th is 16, 3 to the 4th is 81, 4 to the 4th is 256, 5 to the 4th is 625, and then we go to really big numbers, 1296. Now, I do not expect you to have these memorized, of course. You will have a calculator at all times to be able to test to see if the number is a perfect root or not. But let's go ahead and jump right into radicals. Let's go ahead and review. This should mostly be review, I would assume. The parts of a radical, okay? So we're going to do, let me get my highlighter here. Let's highlight this word, which we're about to put in, this word, and this word. So, these words are, what are they? This is called the index. Or the nth root, we can call it that, and just replace n with whatever number you want to do. A is written under here, and it is called the radicand. So that will go here. Radicand. And then up here is, of course, your radical. This is the radical symbol. If there is no index, we, of course, like I said a second ago, we assume that n is equal to 2. Or plain square root. That's what they're talking about, this right here. Plain square root is automatically a 2. All right? Okay, moving on. Now, give all possible roots for the radicals below. Now, these are very specific directions that I want to point out. All possible, okay? That means every single one, okay? A positive and a negative, because it is possible to have a positive and a negative root. For example, 16. What two numbers can we multiply to get 16? 4, right? So it could be 4, but also negative 4, right? Remember when we were doing functions and we were plugging in negative numbers squared always become positive. So it's the same idea here. 4 times 4 is 16, and so is negative 4 times negative 4 is 16. That's what it's meaning by all possible roots. So what we do whenever we have that is we say, okay, if it's all possible, and as long as this has no symbol and this has no symbol, it's plus minus. So we indicate that by putting a little plus minus right over each other in front of the answer. All right, 121 is, and oh, let's talk about the calculator. Let's go ahead and mention that. Go ahead and bring up Desmos. Also, you can have the handheld calculator. I'll go ahead and start with the handheld calculator. So if you want to do square root on here, you will push second, so that's your blue button, and then x squared, because in blue it has the square root button. So you get this, and then you can type in your number you want the square root of, 121, and that is 11. Now, I'll just go ahead and show you the other ones. If you want cube root or fourth root, you have to push math first. So math is under alpha, under the green button. And then choose item 4 if you want the third root. So math and then 4. Or you can do, if you want any square root, you push math and then you push 5. And math and 5, but first actually you have to type in, well, it would help to type in your root first, so the fifth root of, I'm just making that up, whatever. Okay, so that's how you get it in the handheld calculator. Let's talk about Desmos. So you can pull up the keyboard. Okay, remember you can hide and show the keyboard. So square root button is right here. Square root of 121 is 11. Also, you can do this. You can type in, and I looked this shortcut up, SQRT, and it'll automatically put a square root symbol for you there, which is kind of nice. So that's without needing that keyboard. It's a way to do it without that keyboard. SQRT. As soon as I push the T, it changes to that. So, kind of cool, huh? All right. All right, let me jot that down. So, the hand calculator, you want to push second and x squared to get the square root. Other roots, you push math and either 4 or 5. Or Desmos, I'll just put the one you can enter in SQRT. I'll just put this one. And that can bring up your square root symbol. Okay. Alright, so we know that this is going to be a plus-minus answer because we have no positives or negatives, and that was 11. All right, 289 plus minus 17. Okay, fractions. So we just do these separately. So do the numerator and denominator. Let's go ahead and put plus minus. Square root of 4 is 2. Square root of 25 is 5. So we can simply break this down into two individual problems in the numerator and denominator. All right, third root of 8 is 2. Third root of 343 is 7. Okay. Now, let me just say this. You might be wondering, oh, no plus minuses. When we do the third root, we don't do that. Okay, odd roots, we do not put the plus minus. Only the evens, like the second root. Okay, so, but this one, we can do it, but it's just going to indicate like this that they want the answer to be negative. Okay, so this will automatically carry out. And you just do the third root of 125, which is 5. Because these ones are allowed to have a negative under the square root, unlike the square roots. Or under the root. Alright. This one again has a negative, so I need to carry out that negative. Third root of 1 is 1. Third root of 27 is 3. So that answer is negative 1/3. Fourth root of 1. Alright, now, since we're back to even roots, we need the plus minus. And we're going to write that down in this chart down here, so don't freak out. Plus minus 1. Alright, this one, fourth root, is plus minus 7. That's a big number. Plus minus 8. And plus minus again. 3 over 2. And again, yes, check those in the calculator. So, the pattern that is going to happen and indicate is that when you have an even index and the underneath is positive, that means you are going to have what we call, and what we've done 2 units ago, a real number. Okay, so these ones right here in this top row, they have even roots and positive numbers underneath. So they're going to be real numbers. Okay. However, we're going to talk about how you can actually have 2 roots. We're not quite there yet, and they can be a plus or minus. Or, no, we already know that. Yeah, never mind. I was thinking. I'm getting ahead of myself. It's when we have a negative. Alright, we can have an odd root and a positive radicand, so like this one and this one, these first 2 right here. And we also get a real number. So just a regular number in the number system. Those ones give us 1 answer, and it is a positive answer. So what I'm putting here is this type of answers that they are. Alright, if we have an odd number under the radical, we still get a real number. But the answer is negative. So 1 answer, and we get a negative answer. And this is our special case. And we're going to do this more when we get into quadratics, which I believe is the next unit. Let me double check. I don't want to tell you wrong. Yes. So quadratics is coming up next. And we will learn about imaginary numbers. So we're going to go ahead and fill this in. And imaginary numbers also give you 2 roots. They will give you a positive root and a negative imaginary root. Okay. So for now we will, no, I might show it to you. We'll see. I think you can handle it. Alright, let's start out with simplifying. So here's a special note. If you have your directions, pay attention to them carefully when you're doing simplifying. If a radical has more than 1 root, the radical sign indicates only the principal or positive root. So, in other words, the directions will say, I want all roots or not. Like right here, all possible roots. If it doesn't, then we're just going to go ahead and put the only positive one. Okay. Now, these ones actually break down. Okay. So, we can do this a couple different ways. Alright, we're going to start by doing it the way that you probably have done, is the factor tree, okay? So we can take this number and break it down into all our factors, and then remember we circle any pairs of factors that we have, and we put those pairs out front of the radical, and then we have a smaller number inside the radical other than 117. So we'll do it this way first. Now remember a trick, you can see if it has any factors, if it follows any of your rules. Now the rule that this one follows is if you add the digits 7 plus 1 plus 1, you get 9. And if you get 9, that means it's divisible by 3 and 9. So we can divide by, let's divide it by 3, and we get 39. And 39. So those are two numbers that I can multiply to get 117. Then I leave a number alone if it's prime. So 3 is prime. It doesn't have any more factors other than 1 in itself. 39 will break down into 3 times 13. 3 is prime. 13 is also prime. So when I get all prime numbers, that means I am done. So essentially, this is telling me I can do 3 times 3 times 13, and that will equal 117. Alright, now we circle any pairs that we have, and we have, of course, the pair of 3's, which is 3 times 3 is, of course, 9. So we could also say that that's 9 times 13. Now, to simplify this, I take that number 9, but I square root it, essentially, because it's underneath in the first place. So this is 9 times 13, but really I can take the square root and move a single 3 outside. And then I have my square root, and then I put what all my single numbers are, multiply them if you have more than 1, but since I only have 1, I just put that one there. So it's 9 times 13, but I took the square root of 9 already and made it a 3 on the outside. So this is the solution to simplifying, or this is how you would simplify a radical, okay? That should be some review. Let's see how we can do this in the calculator or Desmos, though, because we're going to have a lot of these to do, and this can be tedious, and people tend to make mistakes. So this is another really cool method. Kudos to Mr. Brown for showing this to us. It's pretty awesome. So to do this in the calculator, you do not type in square root of 117, because as we can predict by knowing our square roots, this is not going to be a whole number. Yeah. So what we don't want is this decimal, and that's what you used to do, is just say, oh, well, that's that decimal around to the nearest tenth, 10.8, and we say that's the answer. But no, not in your upper level math. That is not what we do. There is more to it. We simplify it, and there are reasons why we do it like this. So to do it in the hand calculator, so I have both here. I have this one, and I have Desmos pulled up. I'm going to do it in, I guess, Desmos so you can see it easier. You do the same process in each. So what we are going to type in 117, but we're going to type it in without the square root. Then you push divide, and then you type in x squared. And the reason we do x squared is because of my root. My root was a 2. It was invisible, but it was a 2. If you were doing like problem 3, instead you would do a 3, x to the third power, because you have a third root. Okay? So this number right here will change depending on what your root is. So we type that in, and we divide it by x squared. Okay? Now, the graph is there. We're going to get to that in a later at the end of the chapter. But we're not worried about the graph quite yet. Okay, where we're going to get our simplified radical numbers are from the table. So click your settings wheel, push table, and it'll bring this up. Okay, now let's get everybody in the handheld calculator caught up. So if you're using handheld calculator, you go to y equals, which is the very top left button on your calculator, and you type in 117 divided by x squared. So you type in the same thing as in Desmos. 117 divided by x squared. And then next we want to go to our table. So here we push second and graph, which has table written in blue in the upper right-hand corner. So you should see your table. Now, this calculator is a little bit easier to manage because it gives you all the numbers, okay? So you can just scroll through all your numbers and find your answer. On Desmos, however, they only give you some numbers, so you have to add more numbers if needed. Now, what we are looking for is the largest pair of whole numbers where the number in the y column is prime, okay? It doesn't have any more factors. So that's what we're looking for. 1 is always going to show up as a pair of, paired with the original number, so with 117. We don't want that. There's probably going to be more. So on Desmos, we're going to type in 3, and we get 3 and 13. We can type in 4. Now, let me tell you a trick. We're looking for a non-decimal, right, in this column. So this is good, okay? Now, all you have to do is ask yourself, is this number a prime number? Because that's going to be the number under your square root. Yes, 13 is prime. So that indicates that you're done. So technically, we don't have to keep going, but in other cases, you would just keep adding your numbers. 5, 6, 7, and as you see, we get decimals. What we're looking for is a pair of whole numbers with no decimals, okay? And we do not care about the negatives. We care about the positives. So, now, pretty cool, huh? So 3 and 13 show up, and then in your handheld calculator, same thing shows up. 3 paired with 13. You can't go any further because 13 is prime, and look at that. 3 radical 13 is the answer. So you get this number from the x column. You get this number from the y column in your tables. Okay? Let's write this out so that way we remember what we did. So in either one of these, the first thing we enter is 117 divided by, and I'm just doing this off of example 1, divided by x squared. And again, x squared could change to x cubed, whatever. All right, 117 divided by x squared. And then we see the table for both. For Desmos, enter more numbers if you need to. And then look for largest pair of whole numbers. All right. And then we translate that to this. X. Your x number goes out front of the radical, and then your y number goes under the radical. All right, let's do another one. Oh, one more thing I gotta add. No, we're not gonna do that. All right, we don't need plus minus. That's what I was thinking for a sec. Okay, look at number 2. We have a 4 out front. Now, all that's gonna do is just carry down, but I still have to do this 320. So you don't worry about it if there are other numbers. See, in this one, we just happen to have only the one thing. But here, in these, you don't worry. They just carry down, and they're going to multiply by this number that comes out, okay? So let's do 320. And I'm going to do this on Desmos just because it's a lot easier to see. All right, I can take this and just change that to 320. Cheating. Hey, that's not cheating. Saving myself some work. All right, looking for positive pairs. So 1 and 320, that's always going to show up. 2 and 80. 80 is not prime. Nah. So we want to keep going. 4 and 20, no. 20 is, and it's a perfect square. You really want to think of perfect squares. Do I have any perfect squares in 20 as a factor? 4. 4 times 5, and I can square root 4. So that means it's going to be higher. Okay? So I've already done that. 4, 5, 6, 7, 8. And there we go. That's the one we wanted. So 8 and 5. So 5 is prime. And that's going to be our solution. 8 radical 5. 4 times 8 radical 5. Which, of course, now we have to simplify. 4 times 8 is 32. radical 5. Interesting. Now, always a lot faster and nicer when you can do it in the calculator, isn't it? Let's do this third root one, just to see what the difference is, to make sure we're all okay. So 48 radical 3. So change your numerator to 48, and change your denominator to x cubed instead of x squared, okay? That's another thing to keep in mind. Change that the exponent, okay? Whenever your radical, or what was it? Index. I had trouble remembering what it was. When your index is a different number, okay? So let's see, starting with our positives, 1 and 2 and 6. So 6 is, it has 2 times 3, but neither of those are perfect squares. So I think that's where we're going to be at, and let me double check. Yes. So it's going to be 2 radical 6. Now third radical 6. Okay. So no, this number's not prime. So it's not prime number that you're looking for. You're looking for the lowest possible number that does not contain any more factors that can be square rooted. So 2 and 3 are factors of 6, and they cannot be square rooted anymore. So that is going to be our lowest or largest pair, 2 radical 6. So we got 2 times 2, and then when we do our radical, of course our index has to stay the same. And then we can simplify, well, in this case it's third root, yeah, and there's definitely, can't take a third root of 2 or 3, 4 third root of 6. And that is the answer. And you can always double check this if you're not sure, if you're like, you want to just check, alright, let me check third root of 6 in the calculator. Because if that simplifies right here, then you're not done, okay? Third radical 6, which it does not. And to get third radical, again, you push math, and 4, and the third root of 6 is a decimal, so no. As long as this doesn't simplify anymore, or you know of any numbers that can simplify by the third root in 6, it won't work. Okay, let's do one more, just to be sure. 108, so I'll change this, and it's still third root. Alright, here's 1, 3 to 4. Alright, 4 doesn't have any factors that are that can be third roots. So 3 and 4. So 3 times 3, 4, and we keep this right here. So the solution, or simplified, I keep saying solution, we're simplifying. Third root of 4, which we see and we're like, oh, square root of 4. It's third root, which is different, okay? That doesn't become a 2 because of the 3. It's now we need 3 numbers that multiply to get this number, and so that changes it. Alright, let's see what we got going on the next page. Oh, we got some negatives in there. Yeah, let's do a negative. Why not? So, third root of negative 250. Go ahead and do it. And let's see what this one does. Third root of... Alright, to get this in Desmos, I think you have to click Functions, probably under Miscellaneous. Yeah. So to get your nth root, or a different root, different number. Please come to the front office. Thank you. Sorry about that. Third root of negative 250. So again, that was Functions and Miscellaneous, and this button right here will give you an option to type in a different index. 3... forgetting what it is. My memory's horrible. Negative 250. Let's see what happens here. Okay, so yeah, not a perfect square, okay? So that means, well, we know one thing. That negative is going to come out and make the answer negative. We know that. So now we have to do our calculator trick. 250 divided by x to the third. make sure I'm good. Yeah. And I just don't, I do it positively and just take out the negative that way. All right, 1 and 250, so we want to see if there's anything more than 1. So just type in a 3, type in a 4, type in a 5. Oh, that looks good. 5 and 2, yeah, there's no way we're going to have a third root of anything with 2, and 2 is prime. So here we go, so 5 and 2. And there is nothing else that we can do to simplify that. Yeah, that's it. Ooh, a little bit messy. Okay, why don't you try these next 3 on your own. So go ahead and press pause, and then press play when you are ready to see the solutions, to see if you did it. Okay, here are your simplified answers. Number 6. All we had to do is take out the negative, and then there is no number that's the third root of 2 that we can change that to. So that's all we had to do is take the negative out, and then the rest stayed the same. Number 7. So you had to divide 162 by x to the 4th. So make sure you did that. Look at your table, and then you should have seen a 3 and a 2. And so the 3 times the 3 would have changed to a 9, and then 4th root of 2. Number 8, again, divide by x to the 4th. Look at your table, and you should have seen x in the, or x is a 6 and the y is a 2. So this pair right here in your table, and then the 5 out front. 5 times the 6 would have changed to a 30, and then 4th root of 2. So hopefully you did all right on that. All right, let's see now what happens when we have variables, okay? When we have square roots, of course, the exponent, what we want, how we're going to simplify these is by if it comes out of whatever the index is. So we want them to be in multiples of 2, and that makes everything nice and neat. But we know that they won't always be, so we'll see what happens when we get there. Cube roots, so cube roots, we are looking for multiples of 3. And 4th roots, we are looking for multiples of 4. All right, so now this is what can be tricky for people is seeing this and then remembering you got to do these separately, okay? So you might want to get that in your mind. I have to do the radical of 32, and I have to do the radical of my variables. All right, so this is the same thing, okay? We're multiplying these, but we're just breaking it down into 2 parts. So I have to do my square root of 32. Is 32 a perfect square? No, but I know I think I can do this one real quick. It's 4 times 8, and then 4 is 2 times 2, and 8 is 2 times 2 times 2. So that gives me a pair of 2's and a pair of 2's. And then a single 2. So this part will reduce to 2 times 2, radical 2. So these 2 pairs of 2's come out, and then my single 2 is left, giving me 4 radical 2. You can, of course, do this in the calculator, and you should get that. All right, now, a helpful thing that I have found that when you're doing the variable part is to write out the 2, even though it's not there, because it just reminds you, and it's a visual to help you simplify this out. So, again, that's optional. You don't have to, but I'm going to do it for the sake of showing you. So this means we're taking out pairs, okay? Kind of like we did over here. We took out a pair of 2's, and we took out a pair of 2's, and put them out front. We're doing the same thing here. We're taking out a pair of 2's. Pair of 2's out of x to the 4th. So this is really nice. If it goes in evenly, 2 goes into 4 evenly, we are good. So we're going to take out x. And how many pairs are we going to take out? Well, since it's technically 4 x's, we're going to take out 2 pairs of x's. So that would be x squared. So we're going to remove this into our 2 pairs and come out just like we did over here. So that would be x squared would come out. And then now we have to do this with the y to the 9. So does 2 go evenly into 9? No. But we have to take some of it out, as much as we can. So how many times will 2 go into 9 without going over? 4, right? 2 times 4 will give us 8, and that doesn't go over my 9. So I'm going to do 4, okay? Now, sometimes you will have leftovers. Sometimes you won't. This is like, I've eaten my good meal, I took everything out nicely, and now we got to see if we have any leftovers. So, no, there were no leftovers here. 2 went in evenly. Now, there were leftovers here. We took out 8 y's, right? We took out 8 of my y's, and how many are left? 1. So we do 9 minus the 8, and there's only 1 y left. And so we keep that y underneath the radical. Now what we can do is merge these answers together, okay? So this answer has a number out front and a radical, and so does this, okay? But we're going to merge them. So we put usually the number first, and then we put any variables. So I'm going to move these variables next to the 4. And then next I have my radical, and then I put both items in there, 2 and y. Okay, so that is completely simplified. So these are like 2 problems in one. You have to simplify your numbers under the radical and your variables, and they're 2 different processes. Okay, all right. You want to do another one? I figured. I'll leave you that one. Let's do 11. Let's do a third root one just to see how it's different. Okay, so again, and you don't have to break it up into 2 steps every time. If you understand that you got to do this step with just the number and then the other step with the variable, you can. But I think some people will really, it really would help to do these separately. So third root of 216, and then I also am doing third root of m to the third and n to the 6th. So this is where you go to the calculator. Third root of 216. Let's see first of all if that's a perfect cube. Math 216, third root of 216. Alright, so it does. It's always a good idea to check that. Sometimes it comes out as a perfect square. So there is a third root of 216, and it is 6. Nice, so we didn't have to do the table stuff. Okay, now we are doing third root, so this time we're taking out pairs of 3's. How many pairs of 3's are in 3? 1, of course, so we can take out 1m, and we don't need to put the 1, not necessary. How many sets of 3 are in n to the 6th? Yep, 2. So we can take out n squared. This one came out really nice, so we can just push these together, and that's what we get. So sometimes they come out, you know, a little bit cleaner, like this, no square root. Sometimes the square root has to stay. Depends on your leftovers again. Alright, let's go ahead and do another one. That was fun. It's like a little puzzle. Alright, let's split this up. Third root. I know I'm going to have to take that negative out. I'm going to just go ahead and do that. Okay, third root of 64 is 4. Yay! Alright, so if you just put third root of 64, radical 64 in the calculator, you get 4. Let me just show you what would happen if you're doing the table method and you forget that you can check to see if it's a perfect cube or a perfect square. So 64 and then x to the third. So I changed this to 64. Let's see what happens. 1 and 64, 2 and 8. This is what happens. You will see a 1 in the y column. You'll see your 4 and then a 1. And that's what ended up having. A 4 and radical 1 is just 1, so we don't need the square root anymore. That's what you will see, okay? You'll see a 1 in the y column when it's a perfect square. Alright, or cube in this case. Then we do our variables. So how many pairs of 3 are in 10? 3. Very good. Alright, and we're going to have a leftover, definitely. Alright, y. How many pairs of 3 come out of 21? 7. And we have a leftover of, no leftovers here, but we had how many leftovers? We took out 9 of my x's, so I have 1 left. And then this is your answer. Negative 4x to the third, y to the 7th. Oh, I don't want to forget my 3. And then third root of radical x. So be careful of that. The 3, if you run it into your exponents, can look like it's an exponent. So just make sure it's close to your radical symbol. Okay? And there's another kind of longish looking answer. But yes, it's correct. All right. Let's see if there's anything else that looks like it might throw you off. I guess 18. Yeah, let's look at 18. So what this is a single term actually, and you can just do this with the 8 and just compare the 4 and the 8. Now that works because this is in parentheses. So this is a single term, or we're treating it like a single term. So we can see how many times 4 goes into 8, which is twice, right? So we can take out this number y plus 3. That's my number, and it comes out twice. There is none left over. So I can just, you could leave it like that. You also could keep going and FOIL. There are some cases. Remember that y plus 3 squared is the same thing as this. It'll kind of depend on the directions. But just in case the answer doesn't look like this, then that means you got to keep going. Okay, if it's like a multiple choice question. So we'll go ahead and keep going. We'll FOIL. So remember, FOIL first times both of those. So y times y is y squared. Y times 3 is 3y. And then we do it with the next item. Plus 3y. And then 3 times 3 is 9. So the answer could look like that. Okay? It just kind of depend on the directions or answer choices that have been given. So, I think that should be enough to get you to try these. So I would definitely try these. These are not easy. Okay? Try all these and just up to 17. And then pause the video. Go ahead and pause the video and press play when you are ready. Alrighty, so here are your answers. So number 10, 18ab to the third times the radical of ab. Number 12 is 2 times r squared times s times the third root of 7r squared s. Number 14 is negative 3q to the fourth times the third root of 3 times p squared. Number 15 is wv, v raised to the fourth, times the fourth root of v. Number 16 is 2 times m squared times the fourth root of 3 times n to the cubed, or n cubed, I should say. 17 is 5 times c to the fifth times d to the second times the fourth root of c to the third times d to the third. So that's quite a mouthful. So if you have questions on these, come see me in office hours or in class if you need some guidance and you can't figure out where you got stuck. So, all right, I will see you. So I know that was kind of long. This is going to be definitely a longer unit. Next coming up, we're going to add, subtract, and multiply radicals. So see you in the next one.